Imagine standing on Earth 66 million years ago. The ground shakes, the sky turns blood red. In just minutes, the most dominant creatures ever to walk the planet begin their march toward extinction. This isn't science fiction. It's what scientists believe really happened. A single event ended the age of dinosaurs and changed life on Earth forever. But what exactly caused this catastrophe? Was it really just a space rock? Or was there more to the story? Today, we're uncovering the real reasons dinosaurs went extinct, backed by evidence buried in rock, ash, and time itself. Let's rewind to the most devastating day in prehistory, and we're about to explore one of science's greatest detective stories. First, we'll meet the killer, the Chicxulub asteroid. Its size, speed, and the unimaginable power it carried. Then, we'll witness the immediate aftermath: fire, tsunamis, and darkness. Next, we'll dive into the long-term environmental collapse that scientists call nuclear winter. We'll also reveal which creatures managed to survive and why they succeeded where dinosaurs failed. Finally, we'll examine the evidence that proves when and how this extinction unfolded. By the end, you'll understand not just what happened, but how researchers pieced together a disaster from 66 million years ago. Ready to travel back in time? Let's begin with the asteroid itself. The object that ended the dinosaurs was a mountain falling from space. Scientists estimate the Chicxulub asteroid measured about 10 to 15 kilometers wide, roughly the size of Mount Everest. It hurtled toward Earth at approximately 20 kilometers per second, or about 45,000 miles per hour. That's more than 50 times faster than a jetliner. To put this in perspective, if you placed this asteroid in a city, it would span from downtown to the suburbs. The energy it carried was staggering. Researchers calculate it released energy equivalent to billions of atomic bombs detonating simultaneously. When it slammed into what is now Mexico's Yucatan Peninsula, the impact created a crater over 150 kilometers wide. But size and speed are just the beginning. What happened next was even more terrifying. The moment the asteroid struck, Earth experienced hell. The impact vaporized rock instantly, creating temperatures hotter than the sun's surface at the point of collision. A shockwave raced outward at supersonic speeds, flattening forests thousands of kilometers away. Molten rock and debris shot into the atmosphere, some pieces traveling so high they escaped into space before raining back down as fireballs. Earthquakes far more powerful than any in human history rippled across continents. Mega tsunamis, potentially a kilometer high, surged across oceans and flooded coastlines worldwide. Animals near the impact site were obliterated instantly. But even creatures on the other side of the planet weren't safe. The real killer was just beginning to take form. What happened next would doom the dinosaurs. Within hours, the sky turned black across the entire planet. Billions of tons of dust, ash, and vaporized rock filled the atmosphere, blocking sunlight completely. Scientists call this a nuclear winter, though it was triggered by impact, not bombs. Temperatures plummeted as the sun's rays couldn't penetrate the thick cloud of debris. Some researchers estimate the darkness lasted months, possibly even years. Without sunlight, photosynthesis stopped. Plants died rapidly. Herbivorous dinosaurs lost their food source and starved. Carnivorous dinosaurs, who depended on herbivores, followed soon after. The food chain collapsed from the bottom up. Oceans cooled dramatically, killing marine life that couldn't adapt to sudden temperature drops. This wasn't just a bad winter, it was a planetary deep freeze. And it explains why size and strength couldn't save the dinosaurs. Not everything died, and the survivors hold important clues. Small mammals, some reptiles, birds, dinosaur descendants, amphibians, and certain fish made it through. What did they have in common? Size mattered. Smaller animals needed less food and could survive on scarce resources like seeds, insects, or carrion. Many survivors could burrow underground or hide in water, escaping the extreme surface temperatures. Some creatures went into hibernation-like states, slowing their metabolism during the worst conditions. Birds survived partly because some species could migrate and adapt quickly to changing environments. Meanwhile, the huge dinosaurs, needing tons of food daily, had no chance once plant life vanished. Think of it this way. In a famine, a mouse can survive on crumbs, but an elephant cannot. The extinction wasn't random. It followed rules. And those rules explain the world we inherited. How can scientists be so confident about an event 66 million years ago? The evidence is written in Earth's rocks. In the 1980s, researchers discovered a thin layer of clay found worldwide, dating to exactly 66 million years ago. This layer contains iridium, a metal rare on Earth but common in asteroids. It's like a cosmic fingerprint left at a crime scene. The Chicxulub crater itself was found using gravity measurements and drilling samples. Fossilized pollen shows a sudden shift from diverse plant life to mostly ferns, species that thrive after disasters. Fossil records reveal that non-avian dinosaur fossils appear in rocks up until this layer, then vanish completely. Tiny glass beads called tektites, formed from vaporized rock, are scattered globally. Every piece of evidence points to the same conclusion and the same moment in time. The case is remarkably solid. Let's clear up some popular misconceptions. Myth: dinosaurs were already dying out before the asteroid. Truth: fossil evidence shows they were thriving right up until impact. Myth: mammals outsmarted dinosaurs and took over. Truth: mammals were small and limited during dinosaur times. They only diversified after the extinction cleared ecological space. Myth: all dinosaurs died instantly. Truth: the extinction unfolded over months to years as ecosystems collapsed. Some dinosaurs likely survived weeks or months post-impact. Myth: dinosaurs went extinct because they were inferior or slow to adapt. Truth: they dominated for over 160 million years, far longer than humans have existed. Their extinction was about catastrophic environmental change, not evolutionary failure. Understanding what really happened helps us appreciate how fragile even the most successful life forms can be. Let's pause and test what you've learned. Question 1. How wide was the Chicxulub asteroid? Was it closer to the size of a car, a skyscraper, or a mountain? If you said mountain, you're correct, about 10 to 15 kilometers wide. Question 2. What caused the nuclear winter after impact? The answer? Dust and debris blocking sunlight for months or years. Question 3. Why did small mammals survive when dinosaurs didn't? Because they needed far less food and could hide underground or in water. Final question. What rare metal found in rock layers worldwide proves an asteroid impact occurred? Iridium, the cosmic fingerprint. How did you do? These aren't just trivia facts. They're the key evidence that solved one of history's greatest mysteries. Now let's explore why this extinction still matters to us today. Why should we care about something that happened 66 million years ago? Because it teaches us how fragile life on Earth can be. The dinosaur extinction proves that even the most dominant species can vanish due to sudden environmental change. Today, scientists monitor near-Earth asteroids specifically because we know what they can do. Space agencies have even tested deflection technology, like NASA's DART mission, to prevent future impacts. The extinction also shows us how interconnected ecosystems are. When one part fails, everything can collapse rapidly. This has direct relevance to modern climate change, habitat loss, and biodiversity decline. We're currently in what scientists call the sixth mass extinction, but this time it's caused by human activity, not an asteroid. Understanding past extinctions helps us prevent future ones, including potentially our own. The dinosaur story is a warning written in stone. Despite strong evidence, mysteries remain. Scientists still debate exactly how long the darkness lasted. Was it months or years? We're uncertain about regional variations. Did some areas recover faster than others? Researchers are still discovering exactly which species survived and how they adapted so quickly. There's ongoing investigation into whether volcanic activity in India, happening around the same time, contributed to the extinction or just coincided with it. We don't fully understand why some bird lineages survived while others didn't. What made the difference? And perhaps most intriguingly, what would Earth look like today if the asteroid had missed? Would intelligent dinosaurs have evolved? Science is constantly refining this story as new fossils and technologies emerge. The extinction event isn't a closed case. It's an active area of research with surprises still buried underground. Let's bring it all together. 66 million years ago, a mountain-sized asteroid traveling at 20 kilometers per second struck Earth near modern-day Mexico. The impact released energy equivalent to billions of atomic bombs, triggering global firestorms, mega tsunamis, and a catastrophic nuclear winter that blocked sunlight for months or possibly years. Plants died, herbivores starved, and carnivores followed. The extinction wasn't random. Small, adaptable creatures that could survive on little food made it through, while giant dinosaurs could not. We know this happened because of iridium in rock layers, the Chicxulub crater, and fossil evidence that marks the exact moment everything changed. This event reminds us that life is resilient but also fragile, and that environmental catastrophe can strike without warning. If you found this fascinating, hit subscribe for more deep dives into Earth's incredible history. What extinction event should we explore next? Let us know in the comments.